Kyle, it sounded, looks like you shook your head no and then said yes, but I wasn't 100% sure.
No, not according to what you got right there, it goes from -2 to -4. Am I reading that wrong?
Yes, you are. This is I hat and J hat, so those are directions. So it should be understood that I hat and J hat are perpendicular to each other, but let me make it explicit. Not that I hat and J hat have to be horizontal and vertical, but they are perpendicular to each other. Another way of asking the same question about whether acceleration is constant is there a variable in there anywhere?
There should be a T somewhere just to change.
All right, so since there is no T, it's a constant value. Therefore, we got the cake formulas. They still apply. So let's get those down without looking at your notes. Let's see what we can do as a group. Somebody tell me one of them.
V equals
V equals,
VO A plus AT.
all right, one down. If you did VI, that's also fine, and VF here instead of just V, that also works. All right, yes, Max.
Displacement equals VI, or VI plus VF over 2 times time.
All right, two down. Even though on a quiz or test, this will be written at the top of the quiz or the first page of the test, it's still good to know them.
Your position will be Vt plus half of the acceleration T squared.
Displacement and initial time, and notice we switched from VO to VI here,
Okay.
plus, and then what was the last bit?
A half of the acceleration T squared.
All right, one more to go.
VF squared equals VI squared plus NT.
It's 2AS. 2A changing.
With a dot there.
Yeah.
All right, there we go. So we got the four basic equations right there. They're all missing something. This one's missing displacement. This one's missing acceleration. This one's missing final velocity. This one's missing time. There is the initial velocity in all of them. So again, sometimes there's textbooks will give a fifth equation, which is missing the initial velocity, but you can pull it from here. So, which equation should I be using? Or do we just plug in all of them? Pardon? Okay. I have time, I have acceleration, I have velocity, and we can set this up just to sort of get into the habit of making sure we understand the five main quantities here. That's gonna be 3 seconds. This is -2 meters per second squared I hat minus 4 meters per second J hat. VI is 5 meters per second I hat minus 3 meters per second J hat. And I'm gonna make one change here. When I do a problem, I try not to use same numbers before, just so that when you're looking back over it, you're not going, wait a second, which 3 is this? So I wanna change the time here to 6 seconds. Sorry if that really messes up your notes. Let's make the time 6 seconds, because I'm not using the 6 yet. All right. So I didn't give final velocity, I didn't give displacement, but I'm trying to find displacement, so I want the equation which doesn't have VF in it. So the third one. So the long way of doing this, completely accurate, I mean, I guess you judge whether it's long for you or not. So that's equal to 5 meters per second I hat. I'm also not gonna bother writing units. I know what they are, I just need to make sure I have units in the end. So 5 I hat minus 3 j hat times time, which is 6, plus 1/2 negative 2 I hat minus 4 j hat times time times 6 squared. And that's going to be equal to, let's see, let's express this. It's a two-dimensional problem, so I got I hat and j hat in it. So why don't we just call this A I hat plus B j hat. So A I hat. Let's go ahead and distribute here. So this becomes 30 I hat minus 18 j hat minus 36 I hat minus 72 j hat. Combine like terms, negative 6 I hat minus 90 j hat meters. Assuming I haven't made a careless error. So what's A? And what is B?
-6. And -9.
And officially meters. Notice that the 6 here comes from these two terms right here, which comes from this term times 6 and that term times 1/2 and 6 squared. The j components don't affect this at all. Matter of fact, I could X out the j part. That doesn't change this one bit. That stays the same. I'm making the argument that for a two-dimensional problem, especially with constant acceleration, we can treat this as two separate problems. And so let's do that. Questions on this before I erase it? Awesome.
I was just saying, hold on one second.
Okay, Max?
What's the point about the I hat and j hat?
Direction, because vectors have a direction.
Yeah.
It's a way of expressing the direction in what's called rectangular coordinates. Is that sufficient?
Yeah.
Okay.
If you don't include I hat and J hat in your calculations, is it gonna affect the answer?
Oh, if we separate it? We do have to include it at the very end, but we don't have to include it. We can work each side somewhat separately. Well, with the next example, I think we'll hopefully clear that up.
So we got two different answers for displacement?
No, displacement has two components to it. So if we started here, my displacement, I'm going to the left 6 and down 90. So my displacement, not to scale, that's my displacement. And as a side note, Jesse, did I call you the wrong name earlier today?
Oh, no.
Okay. All right, let's go through a problem, hopefully answer Jesse's question. Oh, Lawson, I assume you had it by then?
Yes.
Okay.
So did we finish chapter 3 already?
Chapter 3 is just the vector stuff, we pretty much covered that in one. As you go through it, if you have questions, people will ask. I have a cliff that is, we'll make it 50 meters tall. I'm going to shoot an object up at an angle. Let's make this a 37-degree angle and make this 40 meters per second. So I'm shooting it from the edge of the cliff, and the question is, I think it's gonna go. How far does it land from the bottom of the cliff? So, buying into the argument that we can separate this, I'm going to break it into a horizontal and a vertical problem. I have a displacement horizontally and vertically, I have an initial velocity, I have a final velocity, I have an acceleration, and I have a time. My horizontal, this is my I hat, given my convention right there, and this is my J hat. This is horizontal and this is vertical. Now, you don't have to make J hat up like I did right there. It's perfectly fine to make it down, but just you set up your coordinate system and you live with it for that problem. So what am I trying to find here? What quantity, and then horizontal or vertical, where I've got 10 different slots here. Which one am I trying to find as my ultimate problem?
Horizontal displacement.
Yes. I'm just going to label this as R. That's what I'm trying to find. All right. What do we know?
The velocity.
That the horizontal or vertical displacement is going, well, never mind, because it arcs. Well, okay, the vertical displacement is gonna be 50 meters, right?
Ooh, close.
It's 40 cosine 37.
Oh, you're going for velocity?
Yeah.
Or, I'm sorry, I meant to say vertical.
Yeah, no, you said
I
vertical.
did say
You said vertical
okay.
displacement,
I
and
thought
you're
I
doing
said
velocity.
horizontal for a second.
No, I heard vertical.
Okay.
That's where my mind
I'm
was.
just making sure I'm not going crazy.
So if you didn't say it, we were in sync. All right, so my horizontal velocity right here, I have a vector, which is 40 meters per second. And this is one of the reasons to use I hat, J hat, is the fact that, so we can break it down into a more manageable problem. This angle here is 37 degrees, so my adjacent side here is 40 times the cosine of 37. And the opposite is 40 times the sine of 37 degrees. So as Precious was saying, this would be 40, technically, meters per second times the cosine of 37 degrees. So this is roughly 32, like 31.99 or something like that. And this would be 40 meters per second times the sine of 37 degrees. In other words, I'm making the claim here that my initial velocity in polar form, 40 meters per second, 37 degrees. In rectangular form, assuming that is 32, and this one would be around 24, 24.01 or so. This would be 32 meters per second I hat plus 24 meters per second J hat. All right, what else do we know? We do know vertical, there's enough information to know vertical displacement, but you missed a key thing.
It's 50 plus that height over there.
Nope. This is the beauty of displacement. I don't care about what happens in between.
-50?
Oh, my goodness.
That's critical. If you say positive 50, you're trying to figure out some information for it to be 50 meters above where it started, and you might get an impossible answer. So this is negative 50 meters. That is a common mistake of not putting the negative there. Assuming up is positive. If down had been positive, that would be positive 50, but what else would change? If we said down was positive,
The velocity?
which one?
The vertical velocity would be negative?
Like you mean it.
Would be negative.
Yes, absolutely. Because I throw the object up and it lands below from where I threw it, these better be opposite signs. All right, we have one other piece of information which is understood from this problem.
Vertical acceleration, which is the gravity.
Okay? I guess I need to tell you what planet this is.
Negative 1.79 almost,
7,
7.8.
at least here. There might be some place it wants to 7, but 7, 9. So you want to make it Earth or some Earth-like planet? Some class M planet? I guess that just means breathable. But, negative 9.8 meters per second squared. Why negative? And what about horizontal acceleration?
Would it be 0?
It depends, are we counting air resistance in?
I hope not.
Okay.
All right, so let's just go ahead. No air resistance. So do recognize there is one thing that combines the two. They're not completely independent, otherwise we don't have enough information. But the one thing that binds the horizontal and vertical motion here is time. The ball is in the air moving vertically for the exact same amount of time as it's moving horizontally. So time is the ring that binds them. So how do I find time?
Use what you have and solve for it.
Okay, agree with that. Let's narrow that down some. I have constant acceleration here, so,
The third one.
okay. So I have my displacement is equal to VIT plus 1/2 AT squared. I am plugging, if I plug the horizontal information into it, will I be able to find time?
No.
Why not?
You don't have displacement.
And so we're left with the vertical. Vertical is what actually limits how long the thing is in the air. And so I have negative 50 equals (24t minus 4.9t squared). Now from a solving point of view, if you want to write units in as you go, that's fine, but I'm solving for time. I'm starting with meters and seconds and meters per second and meters per second squared and meters. I'm starting with the nice units, so I'm going to end up with seconds in the end. The other biggest mistake, besides missing the negative sign right there next to the 50, or the negative sign here next to the acceleration, fact that these two, given this problem, these two are the same sign, the velocity is the opposite sign. The other biggest mistake is I see people plugging into this formula. I'm about to write something down which is not the way you're supposed to do it. So I'm gonna put the Mr. Yuck sticker there. Delta S is equal to, oops, 40t minus 9.8t, what happened? 9.8t squared. That is probably the biggest mistake I've seen right there. The other big mistake. This acceleration is vertical, this velocity is at a 37-degree angle. They are not in the same, are not along the same line of the coordinate system. Don't do that. Oh, and then delta S, I guess negative 50. At that point, it's, I see that and I go, no credit. All right, so we're here. How do I solve that?
Set equal to 0, quadratic formula.
All right, so 4.9 t squared minus 24t minus 50 equals 0. Now I'm gonna get two answers. What can you, before we actually do anything else, before we actually solve it, what can you tell me about the two times I'm gonna get? Okay, and then which one will have a greater absolute value, the positive or negative value?
Probably positive.
Yeah, because what the math problem is solving is the zeros, where the thing's initially starting out going up, it's solving the zeros of this equation right here. And so the positive will be the greater magnitude. So t is 24 plus or minus the square root of 24 squared minus 4 times negative 50 times 4.9 divided by 2 times 4.9 or 9.8.
Wouldn't it be a plus 50?
The 50 is already on the left side. It's negative.
Yeah, bring it over to the other side.
No, you brought it over to the other side.
Oh, okay.
It's the scars from my youth. I like the first number. I like the quadratic term positive. You don't have to. I mean, you can be a rebel like Max and just add 50 to both sides. All right, so what are our two answers?
6.48 and negative 1.58.
6.48 seconds and negative 1.58. Now, what time does it reach a peak? Reach this peak right here?
Can't see that.
when the vertical velocity is 0?
That's true, yep. So how would you solve it?
If you, would you just replace the negative 50 with 0 in that same equation?
No, if you replace the negative 50 with 0, you're finding the time when it's here, when it's at the same level.
Gotcha.
So Precious said that it reaches the peak when the vertical velocity is 0.
Oh, well,
So what equation would you use? So, okay, so I have 0 is equal to 24 minus 9.8 t. T equals 24 divided by 9.8, or negative 24 divided by negative 9.8, that's about how you want to do it. And so we end up with something about 2.5-ish,
2.4489.
2.4489.
2.449.
What's the average of these two numbers here?
Two point four five. 4 or 5.
Not just coincidence. So we could have found average time. The way Precious suggested with the formulas, that works fine. Or once we have the zeros, we could just average them. And that'll tell us the midpoint. Parabolas are symmetric. All right, but we digressed. Any questions to hear before we actually solve the problem? All right, so now, what is big R? Besides the pirate thing.
Is the horizontal velocity times time.
In essence, plug it into this equation right here. So we have R equals 32-ish times 6.48 plus 0. There is this other piece right here, but acceleration is 0, so that just, I don't care what the rest of it is. So something where bigger than 180, less than, how about 191? 207. Thank you. All right, questions to hear? All right. Let's take a break. We're going to come back. We're going to take this problem and we're going to keep one thing the same or two things the same, and we're going to put it on Mars. And make sure this is still running. Yep.
I have a question.
All right, I'm going to pause this. Too many times I've done bits and realized I wasn't recording anything. All right, so we've now moved this problem to Mars. You're on the top of a 50-meter tall cliff. You're going to throw it out at some speed v. Still at a 37-degree angle, and it is going to land 207 meters from the base of the cliff. How fast do you need to throw it? This obviously is a harder problem than the one we just did. In my opinion, it is not the hardest of the projectile motion problems. So what do we know? Before we keep going, do we want to change this, or are you good with this coordinate system? I got a thumbs up, so, all right, another thumbs up. I assume those were not rude gestures. So. We got warned. When I was doing consulting, there was a training session for people from all over the world. They said, be careful about the gestures you make, because there are certain gestures, especially in the US, that you make that aren't interpreted the same way. The OK symbol and the thumbs up mean very different things in other places. All right, so we got that.
Vertical displacement,
Is?
-50.
Okay.
vertical acceleration
is,
on Mars? I don't remember what I did on Mars.
Austin spelled tell us. Three point two, 2.73.
Oh, my goodness. That'd be gravitational constant on Mars. Okay, it's not giving me what I want.
It's 2 point something or 3 point something. All right.
I'm looking for the right thing, right? I asked what the gravitational constant on Mars would be.
It's not really constant, so that's, gravitational constant is a separate thing. That should be 6.67 times 10 to the negative 11th in SI units.
3.72
All right, 3.72.
meters per second squared.
What'd you get?
Negative 3.72.
Thank you.
Per second squared.
I was about to write down positive 3.72 and see what mayhem would ensue.
Great.
Since we said up was positive, if we actually did have positive acceleration there, that means we have anti-gravity, which means you throw it, that thing's just gonna go shooting up into the air. It will never reach negative 50 meters. Which comes up with a lot of these problems where if you had done that, if you had made a mistake here, had negative 50 correctly, but you had acceleration wrong, the opposite sign, you should have ended up with a negative under a radical somewhere, or ended up with something that was impossible. And then you'd have to ask yourself, all right, if I throw something off a cliff, is it reasonable that it would never get to 207 meters, no matter what speed I throw it? And it doesn't make sense that it would not work. If I throw it at 0 meters per second, the thing falls straight. If I throw it at 1 million meters per second, that thing is going way past 207. So there has to be something. There has to be an answer.
Horizontal acceleration would still be 0 meters per second squared, assuming no air resistance.
All right. What do we have partial information of? This is all the information that we know directly without any issues. Acceleration of gravity on Mars, that would be on the test, be usually at the top of the first page of the test. On a quiz, if you need it, and I forget to give it to you, just ask.
Do we know the final velocities?
Nope.
The initial horizontal velocity